Hi guys, Buildzoid here, and this is just going to be hopefully a quick video of the VRM thermals of the Asrock B550 Steel Legend, because this is a motherboard that I'm kind of, I think is really cool, mostly because it has a post code, as you can see down at the bottom of the board. So yeah, I'm super excited about the fact that there's now like a sub $200 board with a postcode on B550. Not really much of a, like if you look at historical motherboard prices for boards with postcodes, this is not really that great, but at least we have a postcode. Um, oh, and I've closed the window, and so the VRM temperature is going up now. I love this. Yeah, you test a 250 watt CPU in a small room, it tends to make the room warmer and warmer. But anyway, so the board has now been running Prime 95 with AVX and all of the, like, worst case scenario pretty much for quite a while. So yeah, I'm not going to even bother with the capture card because that would take effort to set up, and I'm too lazy. But yeah, so you can see it's been running for 52 minutes. And the board's been pulling a lot of current, as in, like, let me just turn on the current clamp and I'll show you. So, I mean, the test is still running right now, and actually the temperature, well, the room is getting warmer, so yeah, the temperature will now start climbing up again, because, yeah, so we're at 20 amps on the current clamp. It's like, the thing is, depending on the angle the clamp's at, it'll actually go up and down a bit, so it's probably closer to 21 than 20, but whatever. Um, lot of current, right? It's like 250-ish watts probably going into the board. Um, anyway, yeah, and the room really is it's great. At 23.3 degrees, the board was like maxing out at around 105, and now it's 23.6 according to the thermometer, and now the board is at yeah, now it's at 100. Oh, and now we're at 23.7. Yay! I love my room. This room is tiny. So anyway, let's get back to the board. So that thermocouple that the thermometer is currently reading is not actually the one that you see running right here. That's a different thermocouple. So the one that it's currently measuring is connected under the board, which is really just horrid. So if we look, that's where that thermocouple is connected, and it's just like that's thermal tape and some thermal pad. The thermal pad is to give it better, give the thermocouple better contact. The thermal tape is to actually hold the thermal pad in place. Um, anyway, so that's actually stuck right onto the ground pad of one of the input filtering multi-layer ceramic capacitors, because that ground pad is just stitched through the board directly to the power stage right above it. And so it's a very direct connection to the power stage. In fact, this should give us less thermal impedance than if we had the thermocouple on top of the power stage. So this is probably like one of the hottest spots on the entire motherboard. Unless, well, yeah, this really should be one of the hottest spots on the entire motherboard. Anyway, the temperature just keeps climbing now, which is absolutely spectacular. I was kind of hoping it would stabilize, but yeah, I closed the window and now the temperature's coming back up. Anyway, so that's where that measurement is from. This other thermocouple is just dangling, and we're going to just move it around a bit and check the temperatures of a couple different components at this point. Because the thing is, with the MOSFETs, we don't actually really care that much if the MOSFETs were 120 degrees even. It's not really a big deal. What is a big deal is if our capacitors are sitting at 120 degrees or something like that. And yeah, there's that multi-layer ceramic, but multi-layer ceramics aren't polymers. Polymers like much more sensitive to temperature than your multi-layer ceramics. Not that multi-layer ceramics are immune. Like literally everything has a max temperature, but MOSFETs have a TJ max of 150 degrees. Um, Multi-layer ceramics, usually the ones you see in a VRM, are 125 degrees. Um, and then your bulk capacitors, so the ones right there, those are going to be rated for 105 degrees. Now, admittedly, ASRock uses some of the highest endurance rated capacitors of any motherboard vendor that I'm aware of, as those are rated for a 12,000 hours? Yeah, those are rated for 12,000 hours, which is kind of ridiculous. Most of the other board vendors don't bother with more than 10K. Anyway, so yeah, that's what happens when you unplug a thermocouple. Let's plug in the other one. And so that is just sitting jammed in between the inductors, and that's sitting at 101 degrees. And that's actually not bad, like, because the thing is, we're worried about the bulk capacitors. So on the top side of the motherboard, we're quite a bit cooler because this is where the heatsink is. Also, that heatsink is terrible because that heatsink is at 95 degrees. So yeah, that's like, yep, that heatsink is great. This room is at 24 degrees right now. And that heatsink is doing a great job of transferring heat to the surrounding air, definitely. That inductor over there is around 90, right? So if we go, I'm getting stuck on the GPU, go over here to some capacitors. Oh wait, you can't see what I'm actually trying to... Damn it, did not think this through very well. But anyway, so there we have some surface temperature, 85, yeah, so that's not a big deal. It's like halfway down the power plane. No, 90. It's not really a big deal, though. Yeah, that's fine. You have to keep in mind that I am absolutely hammering the board. This is 250 watts of CPU power consumption. The absolute limit for what you can run into a 3950X is around 300 watts. All right, that upper portion there, it's about also around 90. So yeah, around the middle of the VRM, I think, is the hottest part. And there we're getting... still, you know, like 100 degrees. Oh, wait, PCB. I guess it must be jammed right up against an inductor right now. So that's at 103. But, you know, so that's not the, like, the thing is, there's literally no airflow here, right? I have this foam thing to block any airflow from the radiator getting to the VRM, because I was really hoping, like, basically I was hoping for the board to hit like 90 degrees in a zero airflow environment so that I could go like, yeah, if you're in a case, it's going to run ridiculously cool. But 105 on zero airflow is fine, especially considering like these heat sinks are not meant to be horizontal. The way the fins are cut into them, like there's not that many, like they don't have that much surface area, but they do have some fins. And the way I have these heat sinks just sitting here is definitely suboptimal for their operation. So I'm doing basically my very best to make this motherboard look as bad as it possibly could. And now we're at 107 degrees, room temperature's up at 24. Room temp goes up, VRM temp goes up. So, yeah, that's kind of the thing, is like, I don't really consider this a fail because, you know, we are running Prime 95. We're pushing 240, 250 watts into the VRM. Like, this is not a very realistic workload for a $180 motherboard. This is not really a very realistic workload in general. Most people don't just run Prime 95 on their boards. Though, like, yeah, and also it's like, well, like this is if you were doing maybe like a lot of AVX accelerated video encoding or something like that. This is kind of representative of that kind of situation. The thing is are you really going to have your 3950X that heavily overclocked? I'm not running a ton of voltage here, but it's not like I have much headroom in the way of voltage at this point. I think there's like I could run a bit more, but I don't really want to for the safety of my 3950X. Anyway, let's get rid of this foam and see if the VRM temperature drops. And I'm going to have to put the mic down for a bit, so let me just hang that up. And yeah, see? And that's with the radiator, like admittedly the fans on that are doing 1800 RPM and they are completely maxed out because I actually think this is relatively quiet. So yeah, there's a decent amount of airflow now hitting the board, and it's hitting it through the freaking I/O shield, right? Like there's an I/O shield here. It's not like this is open. This top part, that's plastic. That doesn't do anything for your thermals. If anything, because I have the board horizontal, this is acting as a horrible heat trap. So yeah, and now, you know, with like any amount of airflow, the board, and like if we put the fan, well, yeah, if you have a case with actual airflow instead of this torture test that I set up here, yeah, I don't see a problem with these thermals. And yeah, now it's slowing down in terms of the temperature drop. But the thing is, it takes a while because, you know, yeah. So yeah, I mean, I was hoping for better results, but honestly, I'm not that disappointed. Also, it's worth noting that Asrock is running actually 600 kilohertz switching frequency, which is a little like it's It's kind of high for a like I was like this is a budget motherboard. I was expecting it to run like I don't know 300, 400, 500 kilohertz out at stock settings, but no, it defaults to 600 kilohertz. And in fact, I don't think I saw a switching frequency option in the actual VRM settings of the BIOS. So yeah, now we're under 100 degrees on the freaking back of the board. Like this is not like yeah, I'm not worried about this. At the same time, it is kind of like that thing is technically getting more of the airflow than the actual top side of the board, so might be worth it to switch over to the other thermocouple again and do some topside checks. But thing is, PCBs are made of copper, so if the bottom of a PCB is relatively cool, then the front of it, the top of it should be also relatively cool. They don't have that much thermal resistance compared to, say, I don't know, plastic I/O shields. Oh, there. Okay, well, that's really close to the CPU. Let's stick it in there. Wait, did it seriously drop like... Okay, no, we're back up at 90. Yeah, so I'd consider that fine for a torture test, right? Like, that's... Also, like, this is really quite a torture test. If we ran, like, anything milder than... Or if you had a 12 core, this is not a problem. If you have an 8 core, absolutely no problem whatsoever. So yeah, I'm pretty happy with the results, but I wanted to at least show the like, this is not really proper testing, but it's like, it runs fine. So I don't really see a reason to like complain about the VRM thermals. I still don't get why they run it at 600 kilohertz though. I really should have, like, I'm such an idiot, because well, a while ago I did a big order from DigiKey, and I forgot to order an intersil voltage controller programming dongle. So I could have actually, like, tried messing around with the switching frequency on the board while it's running, actually. That's a really cool part, is you don't have to go to the BIOS. You can just, on the fly, change your VRM settings. If you have a... Actually, no, I might need an Renaissance controller, because this is on an RA 22904 controller, so I'm not sure if the Intersil dongle would work. Like, Intersil is owned by Renaissance, but at the same time, it's like if the branding on the chip is different, it might actually need a different dongle. So, yeah, anyway, yeah, board runs fine. Actually, I'm kind of interested to see how much it cooled down at this point. Now we're at 95 degrees. This is completely acceptable. So, yeah, that's the B550 Steel Legend. I don't really think you need anything, like, well, like, 3950X is kind of, well, honestly, I would just stick a fan on it, right? Like, you've got a postcode, you've got a nice VRM, it just needs some amount of airflow instead of being abused by yours truly, and yeah, I really don't see a problem with this. So, anyway, that's my thermal test for the B550 Steel Legend. Oh man, the video quality at AHOC just keeps going downhill. And I don't really plan to change. Well, I plan to do more VRM, like quick VRM thermal tests like this, because the thing is, like, sometimes you need to actually put a board in a case, right? And that's like if the board, if I was testing it on a test bench like this and it hit like 120 degrees or it shut down or something, then it's like, okay, I need to actually put this in a case and check that under a realistic airflow environment, it doesn't randomly shut down on you. It actually runs. But considering that we are on an open air test bench, the board is horizontal, the heat sinks are not designed for this orientation whatsoever. Yeah, this is fine. I don't really see a problem with this. Yeah, we're at just 90. Now it's at 94 degrees. And again, any amount of airflow, even if inaccurate and from the wrong direction and just, you know, like, it makes a big difference. So, yeah. Anyway, that's it for the video. So I guess thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below, which is how I've got my hands on things like this lovely multimeter, as well as the oscilloscope, which is how I know this runs at 600 kilohertz. And what else was there? Right, Patreon, link in the description. There's also the HOC Teespring store where you can pick up shirts, stickers, posters, you know, the usual YouTuber merch. Yeah, you can click that link, and that also helps out immensely with running the channel, allows me to buy things like the test equipment. So, yeah, that's it for the video. Board still hasn't, like, the thing is, Like, well, actually, you know what? No. That's it for the video. Yeah, I'm going to call it a day for the video. I'm not, like, the thing is, I was kind of, actually, no. I will tell you what the CPU temperature is at. No, CPU is currently at 87 degrees. Yeah. So basically that's the thing is like I was doing some like earlier tests at slightly higher voltages, but the CPU was going over 90 and I don't feel comfortable running my 3950X over 90 degrees with manually set voltages. It's not good for the silicon. So anyway, thanks for watching and goodbye. Which mouse is it? This one. Man, I should set the color on one of these to not be orange so that it's easier to tell. Actually, this one's only orange. Stop the video.